right, we are ready for partial fraction decomposition, and it is a method of rewriting a rational function into a form that is easier to integrate. So you're in pre-calculus and you have not come across integration yet. That's something you learn in calculus. But since pre-calculus is getting you ready for calculus, most of you guys will go on to that. We want to make sure that you're in good shape. So this is very algebraic. There's not a really direct application for this, except for to say that you're going to learn different strategies to be able to integrate functions that are difficult, and so this is one of the techniques that we do. So this is very mathy. Okay, but it's not hard. It's just a method you learn. So here is the thing. The first thing we learn when it comes to partial fraction decomposition is the template or the setup for it. So this is how to set up a rational function. So the first thing you would do is factor the denominator the very best that you can. So if you look at the ones that I'm giving you, these are factored, but a couple of them are not. If you look at number 6, there's two factors in the denominator. One is x squared minus 3, and the other is x plus 2 squared. X squared minus 3 does not factor into whole numbers, so we consider that as good as we can get. So you factor it as the best you can. So after you factor it, then you're going to rewrite it into the template. So this one right here, not this one, there's one further down on the worksheet that we'll come across that points out something that I'll just mention now. You don't rewrite something into partial fraction decomposition unless the numerator of the expression is of a lower degree than the denominator. If the numerator is the same or higher, first you have to do division. You have to divide the denominator into the numerator, and then you would rewrite the rest of this expression into its partial fraction decomposition. Here's the setup. Here's how it goes. You want to rewrite this given expression into a fraction, and this denominator is going to be one of the factors, x minus 2, and this denominator is going to be the other one, x minus 5. Okay, so the rule is we're going to rewrite this into these numbers. We don't know what they're going to be yet, but you want to rewrite it into some other numbers, and what you put up here as a placeholder is something of 1 degree less than the denominator. Okay, the denominator is x to the 1, and 1 minus 1 is 0, so we just want a constant term. A is going to be our constant term right there. The degree of this denominator is 1. We want the numerator to be 1 minus 1, which is 0. We put another constant right there. This is the setup for the partial fraction decomposition. So this is not the full-blown decomposition. To do that, which we're going to do later on the worksheet, you solve for what A and B would be. Right now we're just practicing setting it up. So right here, number 2, this is going to be set up into something over x minus 2 plus something over x plus 1 plus something over x plus 3. What goes in the numerator? 1 degree less than 1 is 0, just a constant. Less than 1, 1 less than 1 is another constant. 1 less than 1 is just a constant. How about this? Then we come across something that is repeated factor. It seems like this would make sense how to set this up, but this is where it kind of takes a little curveball on you. You're like, oh, I get the logic of this. This is how it goes. A repeated factor, you write down the number of fractions as this is being repeated. So first, we'll say x plus 4. And then the second one, you say x plus 4 to the second power. And then the third one's going to be x plus 4 to the third power. So if this is something to the third, you need 3 of these. But it's x to the first power, the second power, the third power. Then you make the decision about what goes in the numerator. Okay, the degree of the denominator is 1. 1 less than 1 is 0, so we need a constant. Okay, here, the degree of this is actually 2. It's quadratic because something's being squared. However, you make your decision on the numerator based on what is being repeated. The factor that's being repeated is just this x plus 4. So that is of degree 1. 1 less than 1 is 0, so this is going to be b. This is truly cubic. 1 less than 3 is 2, but you base it on what's being repeated, which is x plus 4, which is linear. 1 less than 1 is just 0. We get another constant right here. So where is this going to change? Let's skip down here to 6. Let me just make another one of these like this. Let me just change our worksheet. So hopefully by the time you get your worksheet, this will be changed. What will we do here? What if we've got x squared minus 7? This is, oh, did I not do this one? This is squared. Let's do 4 real quick. This is something over x plus 3 to the first power, plus something over x plus 3 to the second power. 1 less than 1, just a constant. What's being repeated is just x plus 3. 1 less than 1 is just another constant, just like that. All right, now, number 5. What if we've got, here's our first factor, something over x. Here's our second factor, something over x plus 2, or x minus 2, okay. Here's our third factor, x squared plus 4. X squared plus 4. What will we do here? This has got a degree 1. 1 less than 1 is a constant. Degree 1. 1 less than 1 is another constant. This is degree 2. Finally, we have something that is the closest you can factor it is squared. What goes in the numerator would be something 1 less than 2 is 1, so we need a linear expression up here. Cx plus d is what we're going to put right there. Down here, what if we've got this expression over x squared minus 3, x squared minus 3 plus something over x plus 2 squared. Okay, this is a repeated factor, so we've got all kinds of stuff going on here. We must repeat it the number of times that it's to the power. So first it's to the first, and then it's to the second. All right, what goes in the numerator? This is degree 2. 1 less than 2 is 1. We need something linear here. Ax plus b is the setup. 1 less than 1 is 0. This is going to be a constant. I'm going to choose a different letter. I've already used a and b. This is really quadratic in nature. However, we base it on what's being repeated, which is linear. So 1 less than 1 is 0. We put D right there. This is the setup. That's how we'll do setup for these decompositions. So I'm going to start the examples we're going to go through. I'm going to stop the video and start it with the examples we're going through.